Start. All right. Good evening, everybody. Welcome to Unit 3's exam review here on AP Calculus Office Hours. We have already got quite a few requests in the chat to start looking at some things on the review guide. So I'm going to do just that. I'm going to jump to number 5 chronologically. I think that's one of the first ones that I saw. And number 5's got some interesting things going on. I can kind of see how this could be a little bothersome. In fact, if you took a look at the answer key, you probably got a little chuckle because I kind of gave up. I kind of bailed out on the problem, if you'll see, but we'll talk about that when I get to that step. So initially, we have this implicit equation, as you can see, and our directive is to take the second derivative. Well, of course, we have to take the first derivative first, and as we do that, the derivative of x squared is 2x. Now when we come across this x times y, we are going to use the product rule. So the derivative of x is 1, I'll write that just for emphasis, multiply by the y, add the x, and now we'll multiply by the derivative of the y. So there we go. And then we finish it off in typical fashion with the 2y with the dy over dx. And then, of course, the derivative of 3 is 0. Okay. Now, whenever you take the second derivative implicitly, and you may remember we talked about this in class, this was the very last example. It was the very last example on the last day of the notes. In fact, a few of you actually saw this today. The rest of you, I think, saw it yesterday. And the key is that you can either get dy dx by itself now, or you could just take the derivative right now the way that this is written. And I'm more of a fan of getting the dy dx by itself. If you absolutely hate this, you could experiment and try it the other way, I suppose. But if I subtract the 2x minus the y over, right, and then I see that this x plus 2y is going to be what's left when I factor out the dy dx, it's very likely that you could just divide that over in one step. And I apologize if I lost anybody there. That's not my intention. I do know that I need to make sure that I'm kind of careful with the space that I have left, because there's quite a bit going on with this second derivative, and I'm going to make sure that we fit it in. So hopefully that works. If anybody's bothered at all by any steps that they get skipped, I'm going to keep an eye on the chat. I got a couple of monitors going here, so I'll certainly see if anybody says like, whoa, record, dude, hold up, don't get it. You know, say that again. I'll be happy to go over that again. So at this stage, we are ready to take derivative number 2. And the notation looks like this. And it hopefully goes without saying, when you guys look at this thing, that the quotient rule is on the mind a little bit, right? That's going to require a quotient rule. So we take the derivative of the top, which is -2 minus dy over dx. So there's the derivative of the numerator. That will now be multiplied by the denominator. And then we subtract the numerator, and we multiply by the derivative of the denominator, which in this case would be 1 plus 2, and then we tack on the dy over dx. All right, and then we're going to put this all over, whoop, there, move down a little bit, all over x plus 2y squared. Now, this honestly isn't going to be a, how should I say, it's not simplified. In other words, we don't have exactly what we want here. This is pretty messy, and we got to fix that. And the problem that's going on with this is that we can't leave dy dx in our answer. That's kind of the issue. So as I kind of indicated in class, these dy dx's that you see that I'm going to highlight here, oops, I didn't mean to highlight the one. These dy dx's that are highlighted, if you go back to this original dy dx step, can just simply be replaced with that, which, you know, that in and of itself sounds pretty easy. So if we make that adjustment, So our numerator is now -2 minus, okay, this ugly, hideous mess of a dy dx. And we continue that here. And we continue over here where we now have 1 plus 2, and then, yep, here it's coming, the -2x minus y over x plus 2y. And then that denominator is still hanging around, x plus 2y squared. And as I said before, if you notice this, I stopped. I mean, I totally stopped right at this stage during the review guide, the key to the solution, the solutions to this review guide. And it's because guys, I didn't have the stomach for this. I mean, I really didn't. We would have to simplify a little bit further. And after looking at this, the first part's not so bad, because if you distribute this guy in, and if I write that first step out, it's not too terrible, because I'd have -2 multiplied by the quantity x plus 2y. And then this minus would drop down, but you can see how these guys are going to cancel with each other. And I'd be left with the quantity -2x minus y. See, all of that's encouraging. That's making me kind of happy. That's making me think that there's hope in this cruel, crazy, dark world. However, that's not going to be the case over here. If I have any hope of getting this simplified, I'm going to have no choice but to get a common denominator among these terms right here. And that's just going to kind of open the can of worms to make this even more complex. And that's not what the intention of the problem is. What I wanted you guys to do is just structure the second derivative, and most importantly, know to make this substitution. All right, and at that stage, if we don't want to simplify, we're not going to simplify. You won't see anything like this ever in your life, especially on any kind of an exam that I will give or the AP would give. But I still like the problem enough to kind of keep it in the notes and kind of keep it in the review guide, and then make that statement that says we're not going to simplify any further. So hopefully that makes sense to you guys. So, all right. Some of the other questions that I saw focus around 7 and 8. So let's just kind of pop down here. Whoop. Let's pop down here a bit and take a look at number 7. Now, I promise number 7's not quite as bad here. There's a couple of different ways that you can do this, and I'm gonna talk about the way that I don't prefer, and that's just the usage of u prime over u. Okay, I tell you, I think there's a time and a place to use this when you've got a pretty simple logarithm. But if you've got one that's a little bit more crowded, one that, say, has the square root over the contents, or maybe one that has a big power wrapped around the contents, I would say let's use a log rule first and then go about our business in trying to take the derivative. So in this particular case, notice I'm not doing any calculus work. So I said y equals, not y prime. But we can see how this expression x squared minus 4x minus 7 technically is raised to the 1/2 power if we ignore the radical for the time being. So that will enable us to bring that 1/2 out in front. Now that does make our lives just a little bit easier. Now, I'm not saying that we completely avoid this. Of course, we have to use this u prime over u, but you have to admit our u prime is much more manageable, right? It doesn't have that chain rule appearance to it. So to take the derivative, I'll write y prime notation. This 1/2 just plops right down, and then we go with our u prime over u, which in this case would give us a 2x minus 4 on top and an x squared minus 4x minus 7 on bottom. And, you know, that answer is correct, but it's very likely that you'll see a 2 factored out of this numerator so that it would cancel away that 2 that we have in the denominator. So we would have an x minus 2 up on top, and then an x squared minus 4x minus 7 on the bottom. And I'm going to curtail tonight by taking the graphing calculator out and checking answers. I mean, you guys have the answer key, so you know if these are going to be right or not. But this is a good problem. I think that this is definitely exam level difficulty. It uses this very important rule. You guys are going to see a few u prime over u's tomorrow or Thursday because of its relevance to the kinds of derivatives that you'll take on the AP exam. All right. Now, number 8 was also requested, which is just, it's sort of a partner question to this, but perhaps number 8 gives you guys even more motivation to bust this thing apart. There is no way that any of us want to take the derivative of all of this. That is one heck of a u prime, right? It's got a quotient rule, it's got a product rule, it's got a chain rule, it's got like every rule known to man in it. So that's not the route that we'll take. Instead, we'll take this h of x and we'll just dissect it and turn it into several separate logarithms. So namely, we would start with the natural log of x to lead things off, and then we would add to sort of facilitate the multiplication that's going on here. We now move to the exponent of 3, which moves out in front of the natural log. We have now the quantity x minus 1. Now for the division, we take care of that by way of subtraction. The x minus 2 has a 1/2 power wrapped around it, so we bring it in front. And then we have finally the natural log of x minus 2. All right. Once you invest the time to do that, now you have a wonderful opportunity here to make the derivative much easier, because term by term, these are very, very simple. The derivative of natural log of x is 1 over x. Of course, the derivative of this particular problem is going to have a 3 in the numerator. And then the derivative of x minus 1 is 1, so nothing else multiplied by the 3. X minus 1 down below. And then over here, we're going to have a 1 in the numerator and a 2 in the denominator. The derivative of ln of x minus 2 is another 1 multiplied by that 1, which doesn't change it, over x minus 2. Now, you'll notice also in the review guide, I stopped here. Again, I don't see what purpose I could possibly serve except by making the class even more difficult than it is by asking you all to get a common denominator there. So we're just not going to go there. Now, had we decided to do the dreaded u prime over u, the one benefit from doing it that way is that these 3 things would have already had that common denominator. But once again, on the advanced placement exam, you're not going to see a problem like that that's going to be combined in such a way. All right. I don't really think that this logarithm differentiation of this variety is kind of their cup of tea. You're going to see much more docile things within the natural log. These are pretty rough things. My thought is if you can handle these, you can handle about anything. We got number 10 that was requested. 10's kind of short and sweet, but I am going to offer an alternative to 10. Maybe my method there is just not really hitting home with anybody. But you know, the way that I would first of all ask people to think about number 10 is just to recall the derivative formula that we discussed in class this unit, that the derivative of a to the x power, right? The formula for that is the natural log of a times a to the x. All right, it's a formula. All right, if you look a little closely in your notes, I did prove why this formula exists, but in order to prove this formula, you have to memorize another formula from algebra class. So that kind of seems to not make a lot of sense. Now, for this particular problem, this one would require more of a chain rule approach. So you're taking the derivative of a to the u power, right? This exponent is more than just an x. So you start off kind of in the same manner. You have natural log of a, and then you have your a to the u, but then you'd multiply by a u prime. So if we just use that idea, then in this particular problem, we can identify the fact that the a is 3, right? The base. And the u, of course, is 5x. And I suppose the u prime is pretty quick to find 5. So that all being said, then, this particular answer starts off with natural log of 3, a to the u, which would be 3 to the 5x, and then we multiply by u prime, which is the 5. And I think my answer key just rewrites this by putting the 5 before the natural log of x, which is, you know, all fine and dandy. If you're bothered by this and you just think that your mind is completely on overload and you don't think that you've got room for another formula, you can do what I told you in class a lot of teachers across the country do, and they just tell their students that anytime that you're taking the derivative of something where x is in the exponent, you take the natural log of both sides. Okay, now already some of you are like, no, I don't want to do this. Yeah, I mean, you got to remember something. I mean, if you don't remember the formula, you at least have to remember a procedure, I guess. Because see, now that you've got this in a logarithm equation, the 5x can come out in front. And I really want you to think of this 5x ln of 3 kind of in a special way. He's special. The 5 and the ln of 3 are just a constant. It's some very ugly decimal that, you know, who knows the answer to? A calculator. And we're going to multiply him by x. Now I'm going to get back to why I did that here in a moment. Because down below, if we take the derivative of natural log of y, we get 1 over y dy dx. Over on this side, if we take the derivative, we got some constant times x, so his derivative is that constant. And now in one final step to get dy dx alone, you would multiply the y over to the other side. Does anybody remember what y is? It's the original problem, right? So you just put the 3 to the 5x right here, and you can see that these answers are indeed the same, just arrived at by two fairly different means. All right, and I don't, you know, I don't grade on one particular procedure over the other. You know, you just want to find one that you're comfortable with. But you guys, I'm gonna, you know, to be real fair, this is a problem that's going to be an issue all year long because you see it so rarely. If it were to show up on the test, it will only be a one and done. You'll see it one time, most likely a multiple choice, and then you guys may see it maybe one more time between now and winter break. It might show up once or twice all during the second semester. As we get closer to the AP exam, probably the day or two before, we'll review the formula just in case it shows up on the AP exam, but it's a very rare occurrence. So, all right. It appears that we got the problems out of the way that were on the review guide. Or actually, I take that back. I'm going to go to 15 here, particularly parts B and C on this one. It's a good robust chart here to have us talk about some chain rule problems. How can I do this? I want to make sure that we can see the chart. That's probably good enough right there. And I got a little bit of workspace. So for 15b, the question gives us this r of x function, and we're asked to take its derivative and evaluate it at x equal 2. I don't know where you guys sit with this, but I am not a fan of the way that this is presented. Do you all see that you could rewrite the g of 2x, and instead of putting it in a square root, we could wrap it in parentheses and raise it to a fractional power? Because it's in the denominator, that power needs to be negative, and then of course the square root means that the exponent would be a half in this case, or a negative half, I should say. All right, so hopefully that sits well with you. That's one of the first things that I did in the review. And then we are now going to go ahead and take the derivative of this, which is going to be a double chain rule. Right? double because we have this whole expression to a power where the expression itself has something besides an x in the parentheses. All right, so if we talk through this very slowly, the negative 1/2 would come out in front, and then we would have g of 2x all raised to the negative 3/2, unfortunately. Yep, it's the negative 3/2. And then just so I don't lose anybody, I'm just going to write down the derivative. I'm going to set the derivative up. I'm not going to necessarily take the derivative just yet. All right. Now, for the next step, if you want to take care of the negative exponent, you certainly could. So we could keep the negative 1 on top, the 2 on bottom, and then g of 2x. You know, a 3/2 power is really nothing more than something cubed and then placed under a square root. I have a feeling that we might prefer it to look that way here in a moment when we start to evaluate it. Once we start to plug in stuff for x, it looks like x is going to be 2, huh? Now on the right side of this, we can just take the derivative of g of 2x, which in and of itself is a chain rule where you take the derivative of the outside, g prime of 2x, and then you multiply by the derivative of what's inside, which is the 2. Hopefully that makes sense to you guys. Now we are going to plug our 2 in for x. About the time that I need the chart, I have to scroll away from the chart. That's just my luck, isn't it, guys? So I've got negative 1 over 2. I'll scroll back up in a moment. And then we have the square root of g of 4. And then whether you square root first or cube first, it makes absolutely no difference. You'll get the same answer. Let's say I want to cube after I square root. And then while I'm here, let's replace this x with a 2, and we have that. So guys, it looks like we need to read 2 things from the chart. We need the g of 4 and we need the g prime of 4. So let's do those sort of respectively. The g of 4 is 9, and the g prime of 4 is 3, so that'll be fairly easy to remember. So I want a 9 here. So let's talk through this, guys. What is the square root of that 9? Of course, you're all going to say 3 because you're smart. And then cube, 3 cubed is 27, right? And then remember the g prime of 4 was the 3 here. 3 times 2 is 6. And now you're pretty much off to the races. You know, you can reduce stuff if you want. We can have a reducing fest. That would be 1. That would be 3, right? Well, heck, I'm having so much fun reducing. Let's keep going. That could be a 1. That could be a 9. And by the time it all is said and done, you're left with negative 1 over 9. And that matches the solution key. All right, so it's a good question. I think Jazz had asked this one. It's a good question. It's not a trivial problem. It has a lot of complex parts to it, but I like it. I think it's probably towards the hard end in terms of what you guys would see tomorrow. But again, why not? You know, if you guys can handle this, probably in pretty good shape. All right. Now C is very, very different. C is a lot more sort of conceptual in that I'm tricking you guys. I'm tricking you into finding 2 derivatives. I mean, I'm guilty. It's terrible of me to do that, but I'm making you both find the derivative of f of g and the derivative of g of f, and figuring out, hey, what are we going to get if these things are perpendicular at 3? So here's what I'm going to do. Let's just divide and conquer here. Let's take the derivative of the f of g of x, and I'm going to use blue ink for that. How's that? So the derivative of that is just talking about the outside f prime derivative at g, and then we multiply by the derivative of what's inside. So boom, just like that, just like that. Now we're going to replace the x's with 3. I kind of feel a little helpless here because I don't have any name to call this function. I want to call it, you know, George or Bobby or somebody, but I can't do that. I guess I could have made up something y, but that's fine. This notation is going to work. If we don't have a name for it, we don't have a name for it. Now, I don't know if you've noticed, but the g of 3 and g prime of 3 are in the chart. They are fairly nice numbers. Well, nice in the fact that they don't have a's in them, at least right now. So g of 3 would be 4. So we have f prime of 4 multiplied by the g prime of 3, which is a half. And then if you go to f prime of 4, what happens? What happens at f prime of 4? Oh, that's just wonderful. We have something with an a. 2a squared times 1/2, which is a squared, right? All right, not quite sure what to do with that, but we'll figure it out later, huh? So now let's go to the other function, the g of f. Now that derivative is going to look kind of similar, but things are going to be sort of switched around, right? So you start with g prime of f multiplied by f prime. All right, replace the x with a 3. Once we've done that, and then we're going to go back to the chart. Let's get all this chart cleaned up and say, okay, what is f of 3? Well, f of 3 is pretty nice, 5, right? We can take that 5. We like 5. 5's cool. F prime of 3 is, okay, Mr. Record Silly, let's go back. F of 3 is 1. I did that backwards. F of 3 is 1. F prime of 3 is 5. There's that 5. I knew I wanted 5 in this problem somewhere. G prime of 1 is, oh, great, something else with an a in it. So 1 over a times 5, of course, is 5 divided by a. Now, you know, kudos to everybody. If you're able to get this far in the problem, if this is a free response question, this is this is great. This is good. And you guys, I'm going to tell you, I'm kind of enamored with this question. And it's one of the problems that sort of didn't make the cut for your unit exam. Don't tell your younger brothers or sisters. I may use this in some capacity next year, either on the unit exam or a quiz. I do like it, but it has to be a free response question because it's got too many parts to it. So what do we do next? Well, basically, you just have to understand that these two things represent the slope of a tangent line, right? You guys know that already. I don't even have to remind you anymore. So then we have to say, okay, we want these tangent lines to be perpendicular, which means that their slopes are opposite reciprocals, if that makes any sense. And there's two different ways that you can do this. If you want, you can take one of the slopes, like a squared, and set it equal to, well, not the 5 over a, because that would be slopes that are parallel. But if you opposite and reciprocate the 5 over a, that's an a, not a q. If you take the opposite reciprocal of that, then you arrive at this, what's called a proportion that you can just cross multiply, get 5a squared minus a, right? Or I'm sorry, let's do that again. 5a squared equals minus a, right? And then you could just add the a over, and then you could factor. And then once you factor, you can see that your two values for a would be 0. And you all see that that's negative 1/5 right there. He is a negative 1/5. And the question kind of alluded to the fact that there could be more than one value of a. So I feel, I guess, fairly good that there's two potential answers, and they are correct. Another way to do this opposite reciprocal thing, and just a lot of this depends on the teachers that you had, but another way to think about perpendicular lines, their slopes, if you multiply them, make -1. That's what it means to be an opposite reciprocal, you guys, that your product is -1. The perilous thing about doing the problem this way is that students would think that you can cancel a's like that. And if you do that, you're going to lose your answer of 0, and that's not a good thing. That's not a good thing. You don't ever want to cancel a variable out like that in an equation. In an equation, you don't want to do that. Now, if it's not an equation and it's a fraction that's just being reduced, that's a different story. All right, so I kind of like this proportion better, this sort of the idea that I wrote there in black. So, all right, before we start talking PPC, I'm surprised that I haven't heard anybody talk about the back part of this review. Just by way of the chat, are you guys comfortable with 25? Are you comfortable with all of this calculator usage? Because you know, if you are, I don't want to waste your time by showing you this. But you know, even if there's just 1 or 2 people that could stand a refresher, I can get through it fairly quickly. I tried to do as good of a job as I could from the standpoint of putting screenshots on the review guide, which would help. But bottom line, you guys, I think there's some easy points for these problems, especially early on, like a part A and a part B. This problem, what you're looking at tomorrow or Thursday, right there is 4 out of 5. 4 out of 9. And it's basically, can you punch the buttons into your calculator? So, okay, AO asked about C and D, which I definitely would love to do those. I tell you what, you guys, let's hit them all. It probably makes more sense. I'll hit A and B as well, and I've got enough kind of yeses on that. So everybody got your calculator fired up? Because I would absolutely love it if you guys could follow along on your calculator. All right, I'll even wait a little bit for you guys. Get my calculator fired up, ready to go here. So, trying to think the best way to do this. If I split screens, I can't really do that very well. So we'll figure this out. I think I'll just do it like this for the time being, and then we'll just move this back and forth as we need it. So, all right, so number 1 thing, let's read the question. It says, for each of the following problems, use correct units. You'll get a couple of points if you guys do that correctly. And round according to the rules discussed in class. You'll get a couple of points for that. Parts A and B revolve around the position of a particle moving along the x-axis that's given by, let's just face it, this is probably the worst equation known to mankind in terms of S of t, right? And for all of you that I had in class today, I think I've mentioned that the x's in this problem should have been changed to t's. If you're in period 7, guess what we're going to talk about tomorrow? But the problem doesn't really make sense if those were x's, so we should change them to t's. All right. So the very first thing that you're going to want to do is to store this into your calculator, because you're going to use this thing at least twice in this problem, and you just don't want to have to retype it over and over again. So anytime that you type a problem into the calculator, and I'm just going to go ahead and make this on the screen. Can I get somebody, last person, Jasmine, would you type yes if you see my calculator? I want to make sure that I'm sharing the right thing. She said yes again. All right, awesome. So you've got the calculator here. So what I'm going to say that we need to do is to store this. So we'll call the function by name, S of t. There's no need to change the name. Just keep it the way that it's written on paper. That'll just make it easier for you. And then you hit the control math template button. That's the button right next to the 9, gives you the colon equal. Okay, now if you're wondering, you can do colon equal also by going down here and choosing the colon, right, typing that, and then you can follow it up with the equal. But you know, seriously, that's like two, get out of that. That's 2 things that you have to type in. So I like the control math template better. All right, let's type this in. Be careful. You're going to power up a trig word. So I would put parentheses in right away. Now you can access the cosine. There's the cosine. Inside of the cosine, you have E. Please make sure you use this button here that I'm highlighting for E. All right. A lot of times a kid will type this in. If you bring it up to the calculator, if you bring this up to me like during the test, I won't say specifically what you've done wrong, but I'll just say you've done something wrong, at which point you'll be like, well, duh, you know. So that's really something I'm trying to test whether or not you guys are adept at using the calculator. So we don't want that. So we want the E here. It's the bold E. And then we have 1 minus t, right? Now be careful where you put this square. You want this square to not be around the E expression, but you want it to be around the cosine expression. All right, and if you think about it, this looks exactly like what you see on paper, doesn't it? Now you're going to add, and then you'll access the tangent from the trig menu, and then you go right back to the trig menu and access the sine, throw your t in. I always tell students, I'm going to remind you this in April, double check what's on your paper with what you've entered to make sure it's right. And once you're satisfied, you can hit enter. I know that seems kind of trivial, but here's the bad thing. If you do enter the problem in the calculator incorrectly, the readers cannot read with you because we don't know what mistake you made. So I want you to use the calculator a lot because the calculator is right about what, 99.9% of the time, right? So that's a good thing, but let's make sure that we put the right things into the calculator. And even if that makes you take an extra 10 seconds, it's time well spent. So now what we're saying is that we want to find the velocity of the particle at time 2. So that means we would take the derivative of this thing. Yes, the derivative of this ugly beast. The shortest cut to take this derivative, there's lots of different ways to do this, but what I try to teach my students is to use the shift minus. Okay, we'll use shift plus a lot next semester for integrals. Don't do something silly and put an x there because we're awful used to putting x's there. We're going to put a t there because we are taking the derivative with respect to t. Okay. Of course, we're going to enter s of t, so we don't have to type that messy thing in anymore. And then once we get out of the parentheses, let's tell the calculator after that derivative is taken, evaluate it such that, which is control equal, you go to the vertical bar, and then you can type in the t value, which I believe is 2 in this problem. And I want to show you something. I don't quite remember what happens here, but I'm going to hit enter. And yes, I was afraid of that. I'm going to tell you, this is a big advantage to being in this review, in this session, or watching it at least tape delayed. Hey, tape delayed people, how you doing? Right? What you have here is an exact derivative, which is wonderful. But you guys, I don't want you to write this on your paper. Are you happy about that? I mean, that would just take 5 minutes alone to write that on your paper, and then I have to grade it. And it turns out that even if you type it incorrectly, I won't give full credit because the directions to this problem says very specifically to enter a decimal, okay? So what I would suggest that you do is after you put that t equal 2, any time that you're using a calculator to evaluate a derivative at a point, put a decimal after that entry, and that will ensure that your final output is a decimal and you don't have to deal with that mess, okay? Now, granted, after we got this ugly answer, you could have hit control enter and it does the same thing. But this way, you don't kind of muck up your calculator screen with all that garbage. Okay, so the answer to this problem would be, I'll let you say either negative 0.855 or negative 0.856. All right, let's say I go with the rounded version. So is there any work that I want to see here? Well, I'm going to tell you, eventually, yes, tomorrow or Thursday, I'm okay. But I would at least like to see s prime of 2 equal, and then I think we said negative 0.856. Okay. If you put an answer anywhere between negative 0.8 and negative 0.9, I will give you a point. If you're in the ballpark, I give you 1 point. If you round it to 3 places or truncate it and include the correct label, which is inches per second, both of those two things would be worth the second point tomorrow. So this particular problem is worth 2, and would you agree that you didn't have to work really hard to get it? It seems like you were pushing a lot of buttons more than anything, and one thing is for certain is the longer I teach, the better kids get at doing that. So, all right. So let's do the same thing here with part B. Notice in part B, we are doing this at a different time. So watch for that because it's easy to screw this up. In fact, I screwed this up on your answer key the first time. Mr. Meunier caught me, but I evaluated the derivative at 2 again. Shame on me. So what are you going to do? Well, you're going to go back to the calculator, and you got a couple of options, guys. You can nest 2 derivatives. In other words, you can do something like this. I don't like it. I'm gonna advise you not to do this, but you could do like a shift minus of a shift minus. Okay, the calculator understands that. It will get that. But you know what's kind of neat about this is that you've already got the notation that you really want to use. You've got 2 d's and a pair of dt's, so doesn't that look like second derivative notation? So if you go to the math template, which we don't use a lot for derivatives because let's face it, to go to that option, it's a lot quicker to do shift minus, isn't it? But they do the same thing. But if you move over to the right just a little bit, that's the second derivative notation, and it's already spelled out for you, right? So you can put your t there, and then you can get your s of t, right? Because this is going to actually do the acceleration now, right? And then we can put the such that symbol. And then remember what I said, I think we're evaluating this at, gosh, I forgot, is it 6? I think it is 6, yes. T equals 6. All right, first person to tell me what should I do after the 6? First person in the chat wins my utmost respect. What should I put after the 6? What should I put after the 6? Period. All right, I'll take period. Period, decimal, Jason, awesome. Anything along that lines that kind of says that this is a decimal type of value, good, good, Emily. Emily, look how efficient Emily was. She just put a period. I like that. So we put a little dot there, and then that means we're going to be guaranteed a nice decimal answer. Who knows what we were going to get if we don't put the period? It probably is pretty ugly, I'm guessing, but I don't even care now. So negative 0.270, whether you truncate or round it. Students will ask, do I have to put the O? And the answer is no. If you just stop at 0.27, I will assume the third digit's a 0, all right? In all honesty, though, I always put that extra digit because I want to make sure that I at least considered 3, okay? What kind of notation? You could put S double prime of 6. You could put V prime of 6. You could do either of those, I guess. But again, on the exam tomorrow or Thursday, I don't have to see the stuff in green. Later on in the course, I will have to see that as we move closer to the AP exam. Okay, they don't want like a bald answer. They need to have some kind of proof where it came from. They need to make sure that you know that velocity is derivative of s. If you guys could start doing this early, it would be so awesome, and it would be just something that you don't have to worry about in the future. I honestly thought about awarding a point for it or a half of a point, but I thought that it was going to discriminate any student who couldn't show up tonight for the review session. I just didn't want to do that to people. So, all right. Now, A and B is where the action is happening. All right. That is where the action is going on here. So what we're going to do here in parts C and D is figure out, first of all, if this derivative is true. Okay, so what we've got here is a graph of a relation, a pretty crazy one at that. And notice that I've stopped this relation so that it only graphs between -1 and 11. And the -1, I think, took care of itself. But I had to stop this after 11 because I may have indicated in class that it just keeps doing stuff like this. It's kind of cool, but it just gets wider and wider and wider, and it keeps sort of kind of getting wavy and stuff. And I just didn't want that much of the graph to be present. All right. So thanks. Let me go back because there was a couple of questions and I screwed up. First of all, Sam, you are 100% right. I do need units on acceleration. I got kind of excited there. The units on the acceleration would be inches per second per second. So in order to get that last pair of points, that last point, we'd have to have the 3 decimal places and the units. Thanks, Sam. And then and then I guess, Max, you got your question answered. Awesome. Okay. Yeah, there's 2 different ways. The vertical bar and the shift minus will be the sort of the procedure to get your derivative and your such that there. All right, keep those questions coming, you guys, and I appreciate you guys helping each other because I can sometimes don't check the chat as probably often as I should here. So for part C, all that we need to do is just take this derivative implicitly and prove that it's equivalent to this. Very similar to what you guys did on the quiz, right? One of the earlier quizzes we had. So if we take the derivative of x squared, we get 2x, right? Equal, and if we take the derivative of -2, we get 0. If we take the derivative of y, we get dy dx. And if we take the derivative of 5 cosine y, we get negative, yes, negative, 5 sine y. And again, we multiply by dy dx. All right. This verification so far would earn you a point. I'd give you a point if you have the derivative taken correctly. The next thing that you have to do is just show me the algebra that's required to get a little farther, and that would be the factoring. So if you factor out the dy dx, that would leave you with 1, a minus, and a 5 sine y, right? Now from this point, you can see that once you divide over the 1 minus 5 sine y, you have exactly what we are hoping to achieve, right? So that would earn full credit. You have a problem very similar to this tomorrow, Thursday, but you don't have the answer given to you. So you're probably going to get more points for it, but it's not, I promise you, it's no more difficult than this. In fact, it might even be a little easier. It doesn't even have trig stuff in it, okay? But for this particular question, I wanted to make sure that this was correct because otherwise it's going to throw part D off altogether. And part D's got some kind of a weird little part to it. It says for y less than or equal to 11, which is pretty much what we see on the graph. It says the graph possesses 3 different vertical tangent lines. Now, that is an outright lie, you guys. And I've made an adjustment to this, and I'm trying to see if yours reflects that. I don't think yours reflects that. So let me kind of explain what I mean by this is a lie. It should say this graph possesses 3 different vertical tangent lines where x is positive. Okay, so I'm talking about these 3 spots here. Do you guys feel that those are 3 spots where there's a vertical tangent line? Right, up and down vertical line. Because see, there's also tangent lines that are vertical over here, right, because of the symmetry of the graph. And I don't really care about those. Those aren't the ones that I want you to find, okay? So it's kind of misleading when you read the directions because if I ask you, well, what is the equation of the vertical tangent line that has the smallest x value? Well, the smallest x value can be sort of interpreted a lot of different ways. Is it the largest negative number? Is it what's going on, you know? So basically, I want you to only think about the blue dots. And I don't know, guys, can you kind of tell which of the blue dots has the smallest x coordinate? Is it dot number 1, dot number 2, or dot number 3? Put it in the chat, folks. Dot 1, dot 2, or dot 3? All right, put it in the chat. Which has the smallest x value? You guys are afraid to answer. We got a 1, Sam, Max, Ao. Oh my gosh, look at that, look at that. Now everybody's gonna jump on the bandwagon. Would you guys feel silly if the answer was not 1? You'd feel pretty silly, wouldn't you? Well, the answer is 1, you guys. It's pretty close, but 1 is the one with the smallest x. And if you're wondering, that's kind of why I gave you the little bit more kind of specific coordinate plane here. I wanted to have a little bit more detail to it. Took this right off Desmos to give you that detail. So basically, you guys, I'm wanting you all to find what's going on at dot number 1. That's what I want to see that's what I want to have happen. So in order to make that happen, a vertical tangent line occurs when the denominator of your derivative, yes, the denominator of your derivative is equal to 0. Everybody okay with that? All right. Now I'm going to show you some interesting things on the calculator. Whenever you solve a trig equation in the calculator, things can get really weird. So let's take a look at this. I'm going to dock B and get all that cleared for you. And then we're going to go into menu, and we're going to go into algebra, and we're going to go into solve, and we're going to solve 1 minus 5, whoops, I was there, sine of y set equal to 0. And then, like always, you have to say what variable you're solving for, so comma y. Now, you may not want to hit your button if you're doing this along with me. Just kind of watch. But if I hit enter, how do you guys like that? What in the world is all of that stuff? It's a correct answer, but it's sort of using sort of the repetitive nature of a trig function and saying like 2 times an integer pi plus the inverse sine. Nobody has time for that stuff. We don't want that, all right? So instead, in order to avoid that, I would love to say that putting a decimal takes care of it, but it didn't. It just turns that yucky mess into a yucky decimal mess. So it takes more than that. All right, I don't even need the decimal. What you want to do is do your such that, just like you do if you're like evaluating a function somewhere. Whoop, let's try that again, guys. Let's do the such that, control equal. There we go. And you want to tell the calculator to only find the values on that very strict interval. Let's go back to the problem. What was that strict interval? It's the one that's mentioned up here. Okay, so if you physically type that in the way that it's written, you're going to get a much more desirable answer on your calculator. All right, this is where I think you guys have a big advantage watching this review session, because I tell kids about this, but it's written out verbally in the solution to the review guide, and you know, some people may not even read it, for crying out loud, right? But at least you guys got a chance to kind of witness it. So you're going to type in -1, and then if you're wondering how to get inequalities, it's in the control equal menu. All of them are there. So less than, be careful, make sure you put a y. You don't want an x, but you want a y. And then another less than or equal, and then your 11. And then, do I need the decimal? That's a good question. I'm going to find out here in a second. Yeah, that's not very pretty, right? At least it cleaned up all of those N1s. So remember when we had the decimal after the 0, or after the 2, or after the 6? Let's see if that makes a difference in this kind of a problem. And the answer is yes, it does. So all of those little tips and tricks are going to really help you guys, not just in Unit 3, But from here on out, it's very likely that you guys are going to solve equations like this almost every single unit, and you will get your calculator, and this is the way to go about doing them. All right, now I know you're going to look at this and you're going to think, oh my gosh, there's a lot going on here. There's a lot of answers. Well, yes, there is a lot of answers. So let's do this. There's actually another answer, the 9.22, that I had to scroll over to get. So if I scroll back, you can kind of see all of the answers except for the 9.22. So what I wanted to do is I'm just going to like drag this into the notes here so that we can kind of see both. I just want this to be visible along with the graph. And then how about I put equal 9.22 right down there so we have it, okay? So basically, you guys have gone downtown and you're going to pick somebody out of a police lineup, right? Who is the culprit who's going to match this point number 1? So the first person comes up and it's y equal 0.2. Do you think y equal 0.2 is where number 1 is? Of course you don't. That's probably the 0.3 here, isn't it? Y equal 0.201 or whatever. Yeah, it looks about right. It looks to be about where 0.2 is. So that's not the one that we want, okay? Check this one out, guys. 2.9. Y equal 2.9. Where's 2.9? Yeah, somewhere along here. Do you remember tonight when I told you that your calculator gives you correct answers 99.9% of the time? Welcome to the 0.1% of the time. Sometimes goofy things happen and the calculator spits out information that just doesn't exist. It's not there. It's not anything that you need to be upset about, but you have to trust me in that I will always provide a graph in this situation so that you can back up your findings. So 2.9 is just absolute garbage. Okay, let's go to the 6.4 number, which happens to be, that's where the 2 is. In fact, that has the largest value of x, if I'm not mistaken, right? It's farthest away from the y-axis. So he's not right. So I wonder if the 9.22 is right. Do you think that that looks like it has a y value of 9.22? Of course it does. Of course it does. So when you find this solution, the y that you want is 9.222. Now, not to burst anybody's bubble, but that's not the answer to the question. And the reason it's not is because we want to find the equation of the vertical tangent line. That just tells us what the y coordinate is there. Doesn't a vertical tangent line have an equation that looks like x equals something? Am I right? So you have to take this 9.222 and plug it in somewhere. Where do you think you're going to plug it in? Whoops. We're going to plug it into the original expression. Okay? And once we do that, we should be able to solve for the x. So I'm going to take you right back to the calculator. It's coming back on the screen here, hopefully. And man, there's a lot of stuff on our calculator screen here. So at this point, we are going to just focus on the right side of that equation. Now, you guys, if it's in front of you, it has to be like on a piece of paper because I got it covered up here. But we're going to go ahead and take -2 and add y. Well, guess what y is? 9.222. And then we are going to, what is that? Add 5 times the cosine of 9.222, and we end up with this answer, 2.32445. Now, if you look back at your notes, that's what x squared is equal to now, am I right? So we know that x squared is equal to that expression that we had on the calculator. I will bring it back up in a moment, but it was 2.32445. Get out of the way here. 2.32445. Is that what I said? We'll find out here. Oh my gosh, I've lost my calculator. Which screen is my calculator on? It's gone, guys. It's gone. There it is. No, it's not there. That's the thing that I drug over. That's a screenshot. Sorry. I'm not kidding you guys. I've absolutely lost my calculator screen. I've got like 3 monitors going here, and it's like it's nowhere to be found. Is it underneath stuff? Is it underneath this? Nope. That's keep calm. Keep calm, everybody. Keep calm. Yeah, I'm clicking on this and nothing's happening. So, yeah, I'm really disappointed with that. So, I'm not so sure what to do. How about I start the software again? Let's see if this works. But anyhow, what I am trying to show you is that we would have to take the square root of this number to get x by itself. And the square root of that number, as you can see, is going to yield a positive and a negative. And the negative is going to be that value that we don't want. And the positive is going to be this value. And I would love to show you. You have no idea how deeply, desperate I am to show you that the answer is 1.525. And does that look like the x coordinate of that particular point? And that is the answer, x equal 1.525 for that problem. Okay. Yeah, still going to try to figure out what the heck is going on with you. Thank you, Max. Thank you, bud. I don't want anybody to be intimidated by this problem. There's a lot going on with it, but most of it is just your comfort level with the calculator. And, you know, now's the best time more than any to not be afraid of your Inspire and use it every chance you get. Normally every now and then I'll hear a grumbling of a group of students who don't like to use it. I have never heard that from any of you. And it includes you guys that I had as sophomores last year. So that's good. I think that means that we're probably going to have a pretty easy time whenever we're going to use it. So that's what we got there. So, all right, let's take a look at some PPCs. What do you say? PPC time here for the next half hour or 27 minutes. If I go back up to the beginning, we had some PPC requests that go all the way to number 6 and number 18. And number 8 also has, or 5, I'm sorry, has made the list. So right now I've got 5, 6, and 18. I'm going to write those down. And let's cut them out. I've already got my PPCs up. I'm prepared, guys. I'm prepared. We should stream this. We should put this on Twitch, everybody. We would have 2,000 viewers. You know it. This is exciting stuff. All right, so I'm going to copy this problem 5 in. Okay, Emily, if by some weird chance this is not your problem 5, speak up now or forever hold your peace, but I'm pretty sure that we are dealing with the same 5 right there. All right, hopefully that's big enough that you can see. Sam, yes, baby. It's actually High Jumper 111. You guys want to follow me on Twitch? You can follow me, guys, right here. Help me make affiliate right there. That's my Twitch stream. HIJUMPR 111. High Jumper is sort of metaphorical for jumping high, reaching your full potential. But yeah, I expect a huge influx of Twitch followers tonight. All right, so for this particular problem, we are going to take the derivative of both sides. And the derivative of sine is going to be a cosine, of course, of the x plus y. And then we multiply this by the derivative of what's inside. And the derivative of what's inside is 1 plus the dy over dx. Okay, so does everybody feel pretty comfortable with that aspect, with that part? Right, cosine quantity x plus y, and then times 1 plus dy over dx. Because the right side is the piece of cake. The right side, the derivative of 3x is 3, and the derivative of negative 2y is 2 dy over dx. Okay? Now, the problem with this question is that it's a little bit unkind in that these parentheses have to be busted apart before we really can have any hope of getting the dy dx's together. And sometimes it's just a matter of making sure that students are comfortable counting how many terms. So I want you to all know that this cosine of x plus y counts as one term, but inside the parentheses you have a pair of terms. We need to multiply this one term that's outside by both of those terms. That's what will bust up those orange parentheses. So if we do that, cosine of x plus y times 1, it's pretty self-explanatory, plus, and then the dy over dx multiplies by cosine of x plus y, just like that. And then the right side is sitting and waiting patiently. And I think we're now at a point where we can get the dy dx's together. If you count, there are now 4 terms in the problem, right? Terms are separated by pluses and minuses. So I'm going to add the 2 over to the right. And subtract the cosine of x plus y to the left. Did I say x plus y? Yep, this should be a plus, you guys. That should be a plus. All right. So what's happening now? You can factor out this dy over dx. That's going to be multiplied by 2 plus this cosine term. But isn't the 2 plus the cosine term just going to divide over and be in the bottom? Meanwhile, this 3 minus the cosine term is going to stay up on top. And then luckily for us, this does match choice D. Okay. And one thing I'm happy about, and you guys probably will be too, is the AP exam, no, they're not happy with killing baby seals and canceling those, but you're going to see that that particular mistake won't be reflected in a choice, right? It's not the AP algebra exam. So we're good there. All right. So good question. I think it was Emily, that asked that. Pretty challenging. I think anytime that you got to bust apart those parentheses makes things pretty tough. Okay. You guys had asked about my streaming. I don't stream very often on Twitch. I do the streaming I do is RPG games. I do a little side work for a couple of companies with some production and development, and so I run their software. It's just a virtual tabletop that we play these games with, and we have a group across the country that kind of messes around with those. Yeah. Let's go ahead and take a look at some more PPCs here. Got a lot of them coming in now. I know that 7 was on the list, and what happened is I wrote them down and I smeared them with my hand, so I can't see them anymore. So 6 was 1 and 18 was 1. So let's move to 6 here. Let's move to 6. A lot of stuff going on here in 6. Can I get this all captured? Man, 6 is like the world's longest question here. So, all right, I'm gonna move this over. I'm gonna move this over and capture 6. Copy. Okay, this one very likely could be kind of small on your screens. especially if you're watching from a small device, tablet, heaven forbid your phone, but it's okay. I don't judge. It's just going to be really hard to see this, you guys. Let's see what we got here. It says the point -2, 4 lies on the curve in the xy plane that's given by the equation f of x times g of y. I'm going to rewrite that. F of x times g of y equaling 17 minus x minus y. F is a differentiable function of x, g is a differentiable function of y. Selected values of f prime, g, and g prime are given in the table. Our job is to find what is the dy dx value at the ordered pair -2, 4. So it looks to me like it's just an implicit differentiation problem, but it's got this really bizarre product at the front. All right, so it's manageable. It's certainly within the realm of what we've talked about in class, but it's this kind of problem, you guys, that I want to get you guys to not panic about, like if you were to encounter this on the AP exam. Because here's why. If this problem's on the AP exam, it's going to be missed a lot by a lot of people across the country. We don't want to be those people, right? I mean, you can still miss a problem like this and easily get a 4 or a 5, but why not pocket some of those more difficult problems, bank the points because we've practiced them. So product rule right off the bat. So we have the derivative of f of x times g of y plus f of x times, here is the tricky part. What is the derivative of g of y with respect to x? Well, we take the derivative of the outer part, g prime of y, but can you predict what we're going to tack on? A dy over dx. Yep, that's the left side. That takes care of the left. Now for the right side, much easier. We have 0, derivative of -x is -1, and then the derivative of y is dy dx. Okay. Now we can insert -2 for the x's and 4 for the y's. And I'm just going to go ahead and do that right across. -2 for the x's and 4 for all of the y's. The dy dx stays as is. The dy dx stays as it is. Now, why did I do that? Why did I plug in before solving for dy over dx? Could I have solved for dy over dx? Of course. But I think by plugging the numbers in first, it's going to make the problem a little bit more manageable. Again, you're going to have to squint to read some of these values, but f prime of -2 is 4. G of 4 is 5. F of -2 is 3. G prime of 4 is 2. Then we've got the dy over dx. And on the right side, -1 minus dy over dx. So just really take your time. Be careful with your terms. 20 plus 6 dy dx equals -1 minus dy dx. Right? Now, just pretend dy dx is like any normal variable, like x, like what you saw in your algebra class. So if I add 1 dy dx over to the left, I would have 7 dy dx's. If I subtract 20 to the left, from the left to the right, I have -21. Oh, and I have a dy dx that's going to be a nice integer. -3 is the answer. So neat problem, a little different, a little bit on the different side there, but pretty cool nonetheless. I like that. All right. I know that 18 was requested on the PPC and 7, and then we also have a few more requests for some that were on the review, and I can go back. If we go over time a little bit, I'm fine with that. I do know that the longer I go, the more time it takes to process. So I'm going to try to get this all fixed and processed by 11. If we stop by about 9:15, I probably can get this all fixed by 11 o'clock. So let's take a look at in order of them being asked. That would take us to number 18. So this is the very last PPC question that you had, not necessarily that we're doing, but the last one that was in the assignments. View, snipping tool, there we go. You guys gotta love the small PPCs. I think the next unit has about the same amount as this one. They start to get a little bit larger, but never like they were in unit 1. That was crazy, having what, 48 or 45 of them or whatever. So here it is. This one you can actually see. Lovely. All right, let's take a look at this guy. Let's lock it in place first. Lock in place. So we read it. It says y equal f of x is a twice differentiable function. That just means that you can do stuff to it. Don't worry too much about that. F of 1 is 3. The derivative is given. What's the value of the second derivative at x equal 1? Oh, this is interesting. It's an implicit second derivative, but they did us a favor, you guys. They got us started. We already have the first derivative. We just have to take the derivative of this derivative. All right. So if this thing is having a dream, it's going to be thinking of calling itself 4 quantity y squared plus 7x squared, all raised to the half power. All raised to the 1/2. Let's see if we can write 1/2. There we go. That's close enough, right? So we take this derivative using the chain rule. The 1/2 comes out in front, multiplies by the 4. There's our 2. Quantity y squared plus 7x squared sticks around. We lessen the power by 1, -1/2, and then we multiply by the derivative of what's inside the parentheses. That would be 2y times our dy dx plus our 14x at the end. Okay? So that is a correct second derivative. It's just that they want us to do more, right? They want us to fill in some values. They want us to let x be 1. Okay, so this x is going to be a 1, and that x is going to be a 1. And then they want y to be, what the heck do they want y to be, guys? What the heck? They say that f of 1 is 3, but what does that say about y? What's the y? I know that the x is 1, guys. What the heck is y? Anybody in the chat help me? What do you think y is? If x is 1, they didn't tell me what y is. Nobody? Thank you, Jason. It's 3. Yeah, good, Emily. You guys got it now, Sam. You see what I'm saying? They don't specifically just like hammer it over the head like, hey guys, y is 3, but it's just that little bit of piece of information here that just says the x is 1 when the y is 3. Okay, so we just go into this thing, replace the y with the 3. So this is going to be a 9, right? And then 7 times 1 squared is 7. Oh, look at the wonderful favor they did for us. 9 plus 7, 16, perfect square. Doesn't get better than that, does it, kids? 2 times 3 is 6. There's our dy dx. 14 times 1 is 14. Now, if I could just get you guys to simplify this, but wait a minute. Wait, what the heck? What the heck are you doing in there? Do you remember what we had to do with the dy dx before? Replace it with this. Can you imagine that being replaced right there? And if it is replaced and we let the y be 3 and the x be 1, guys, I want to say that we get a 9 plus 7 underneath the square root, right? Square root of 16 makes this a 4, and then multiply by the 4. So that question mark is just the number 16, isn't it? So when all is said and done, you've got 2 over the square root of 16 times 6, what? 6 times 16? It's too late to do that. That's 96 plus 14. All right. 2 over the square root of 16 is 2/4, so that's just 1/2. So whatever 96 plus 14 is, which is 110, would be divided by 2, right? 2 over 4 is going to be 1 over 2. What is that, 55? Boy, is that a choice? I'd be happy if it were, and 55 is definitely correct. Definitely correct. So good, guys. Nice. I don't want to shortchange our PPCs. There's one more that was requested. It's number 7. And then after that, let's do a real quick turnaround and take care of the problems that you have in the review guide. The reason why I wanted to do the PPCs first is that you guys don't have any means by which to check the PPCs. The review guide, at least you could, I guess, you could look at the review guide solution key. So I got to snip this in 2 pieces because Newhamin has to give me a problem that has a graph. She has to do that. So the graph just gets done separately. It's okay. It's actually good that you guys have asked about a graphing problem. So we're going to go ahead and shrink this, and it's down this big, and then I'm going to snip the question. All right. Thanks for being patient with the snipping, you guys. Okay, so now it's a matter of how can I arrange this? Is there a way that I can bring this forward? Bring forward, order, bring to the front. There we go. So put that there. Again, you guys are probably going to struggle a little bit if you're viewing this on a very small device. Okay, so it says the graph of the decreasing differentiable function f is shown actually below. Also shown is the line tangent to the graph of f at the point 4, 6. I'll buy that. G is the inverse of f. Which of the following statements is true about G prime? I like this. I like this. This problem can be answered very quickly, and everybody needs to give Newman a pat on the back because you're going to see something like this tomorrow or Thursday. All right, so let's talk about this. What is the slope of this tangent line? Is that something that we can compute? Now, if we look at this pretty closely, we have a point right there, and I'd say that there's a point up here at 0, 9. So the slope looks like it's going down 3 units over 4, right? Now, if you're kind of wondering if that's really true, is the point 0, 9 really on the graph, try going down 3 again and over 1, 2, 3, 4. Does it look like you have another nice point? And I'd say you do, okay? So the slope of this tangent line, and this is the tangent line to f, is -3/4. Nobody's going to refute that, right? Well, when they ask you to find the derivative of g, that would be the slope of the tangent to g, right? But they also say that f and g are inverses. So you've got to pick up on something very, very subtle that we talked about in class. And that is that the slopes of the tangents to inverse functions are blanks of each other. I'm going to give you guys a couple of seconds to think about that. And if you want to, you can throw it into the chat. All right, throw it into the chat. The slopes of tangent lines drawn to inverse functions are blank of one another. And if you don't know, if you're not sure, that's fine. By you not answering, it definitely tells me something. So we did this right at the beginning of the discussion over this, and I ended up graphing a couple of things to show you this. Jason says reciprocals. Jason's right. They are reciprocals of each other. So all you have to do is find the reciprocal to -3/4, which is -4/3. Now notice, it's not opposite reciprocal. It's not perpendicular stuff that we're talking about. It's just reciprocal. And you guys, that's kind of why the inverse formula for derivative has that 1 over. That's the whole idea of the reciprocal that's happening. Okay, you have a problem on your test very similar to this. And a lot of kids are probably going to miss that question unless they view this session or really go back and look at the beginning part of their notes. So I think you guys have it. I think you guys have got it. Oh, Jason, let me think about this. I wasn't real careful here. I am embarrassed. The answer's C. Thank you. I should have read through the choices a little bit better. If you look, A and C both have -4/3. Why is the answer C? Well, it's because the x coordinate of the f function is, let's say that again, Mr. Record. The y coordinate of the f function is the x coordinate of the g function, right? That's the one that's got to be true, all right? You guys won't have to worry so much about that aspect. Your problem is more about just recognizing the reciprocal relationship. It's a problem that you can answer within 10 seconds, and if you have that body of knowledge. So, okay, but yeah, he's right. It should be G prime of 6, so it should be C. Should be C. Okay, I'm going to try to go back up. I know 21 was very favorably requested back on the review guide. So let's back up and see if I can find 21 here. Definitely don't mind doing this. 21, there's 21. It's a good one to take a look at. All right, it says that f of x is this pretty ugly radical expression, and it says that g is the inverse of f. We're given that f of 0 is 3. They want us to find the value of the derivative of the inverse. So if you get kind of mixed up with what this g is all about, I wouldn't really worry about it. If g and f are inverses, anytime that you see g, just replace it with an inverse. So g replaces with inverse, put the derivative with it, put the of 3, and then you're all set to use your formula, right? Which is 1 over f prime of the inverse of f at 3. Okay? So really you have two things to do here, and you can do them in either order you want. You need to find the derivative of f, and you need to find the value that goes with this f inverse. All right? So why don't we take the derivative first? If f was having a dream, the dream would be, I no longer have a radical surrounding me, and I'm instead raised to the 1/2 power. Even outside the cloud, I'm raised to the 1/2 power. So that means that f prime would be a 1/2 in front, followed by the e to the x plus 3x plus 8, all to the -1/2, multiplied by the derivative of what's inside, e to the x plus 3. All right? That's a pretty messy derivative. I'll give you that. There's a lot going on there. All right? The next thing that we need to do is find f inverse of 3, which basically is us letting the y value here be a 3 and solving what's left. Right there, right? Now, if you look around problem 21, you're going to notice that it does not have a calculator icon. So what that means is you can't use a calculator. Well, that was pretty prophetic. Aren't you glad you have me to guide you? We can't use a calculator. So that means there must be a pretty nice value of x that will make this work, and there is, you guys. And if you would rather square both sides before you figure that out, you're welcome to do that. You don't have to. But let's just start with our good friend 0, and let's see what happens. Anybody notice what happens when you let x be 0? When you let x be 0, you get 9 on the right side, am I right? Because e to the 0 is going to be a 1. So you've solved it by just kind of investigating the possibilities. okay? So now getting back to this blue stuff, you're going to have 1 over, and then this is the part that's a little messy. All of this stuff is in this denominator. And the way that I'm going to present this is I'm going to write this where the e to the x plus 3 is in the numerator, the 2 is in the denominator, and then I'm going to put the square root back over this e to the x plus 3x plus 8. I'm going to do that. And then I'm going to evaluate this at that x that we found. All right? So when doing that, the e to the 0 is 1 plus the 3, so I have a 4 in that numerator of the denominator. And the bottom would be 2 square root of, and guys, I think we just did this. Didn't that give us 9 a moment ago? So the 4 over the 2 would cancel. So I have 2 over 1 times 3, right? Which is 2/3. But since that's in a reciprocal fraction underneath 1, wouldn't that give us 3/2? And I've got the review key here just to make sure that not only am I right, but if I'm not right, I want to make sure that I correct the key. So there you go. And I think that my notes are a little bit better if you look at the review key, but what my notes lacks is the interactiveness. It's me being able to explain things verbally, and I hope that makes sense. Those of you that were asking on a Shriya or whatever, those of you that were interested in problem 21, if that helps you a little bit. So you guys, I know there's still a lot of requests out there. The only thing is I want to make sure that we finish by 1/4 because I got a feeling I think the stream might just end automatically for us anyway, because it's got a sort of a limitation when I first initially put it together. So I had a request for 20 and I had a request for, I believe, 17. So doesn't really matter which one. Let's take a look at 17 first. We might be able to get both of these in, you guys. Let's try this one. So for 17, we've got an implicit equation, and we have a derivative that we want to take. So we'll jump all over that. Derivative of 2x is 2. Derivative of y squared is 2y dy over dx. Here's the part that's very tricky. You have a minus that's coming before an impending product rule. So drop down that minus, put your parenthesis, take your product rule. Right? You guys have done the derivative of x times y quite a few times. You're probably getting used to it. And of course, that's going to equal 0. All right, let's clean this up because this thing is pretty filthy right now. So we'll distribute the minus. And move stuff over that doesn't have a dy dx. So I'm going to move the y over. I'm going to move the 2 over, subtracting it. And then you guys can probably see that there's a 2y minus x that would be left once you've factored out the dy dx. Does that seem logical, guys? So that's what you would have on the right side. So we have found our derivative. Okay. If it wants to know the equations of the tangent lines, that sounds pretty plural, doesn't it? The equations of the tangent lines at x equal 1, then we're going to have to do a couple of things. The first thing is we have to know what the y value is when x is 1. So you just return to the original problem, and we are going to replace all of the x's with a 1. That's going to enable us to solve this. So if we do that, y squared minus y, subtract the 4 over because we have no choice but to solve that equation set equal to 0, break out our algebra skills, and that would be skills with a z, everybody, and factor into y minus 2, y plus 1, and there's your y values. Okay, and you know, depending on how much of a math nerd you are, you guys are welcome to graph this. It graphs nicely on your Inspire or Desmos. you'll see that there are two places where the tangent line exists when x is 1, right? It has two different tangent lines when x is 1. All right, so what we then have to do is figure out what the slope is at each of those lines, right? One occurs at the point 1, 2, and the other slope will occur at the point 1, -1, right? So if we just replace the x's and y's with 1 and 2, up on top, this is going to be easy, guys. 2 minus 2 is 0. Now the denominator is going to be what? 4 minus 1, but that doesn't matter. So we have a slope of 0. That's easy. And then for this other slope, -1 minus 2 on top gives us -3. And then for the bottom, I've got -2 minus 1. I got -3. I want to double check that. 2 times -1, -2. Yep, that's right. So that slope is +1. So now you write the equation using point slope. Now this one's kind of funny, but let's do it anyway. Y minus the y value equals the slope, quantity x minus the x value. I'll admit that looks a little silly, but I would award credit for that. But the right side is just wiped out, and if you add 2 over, you get, well, the equation of a line that's definitely got a slope of 0, a horizontal line. And then over here, for the slope of 1, you'll do y minus -1, which is that, equals m, which is 1, quantity x minus 1. And we're going to leave it like that. Okay? I like part C in that it sort of builds upon what we've talked about already with vertical tangent lines. And just whatever this is worth, this was a former test question, guys. This was a problem 17. It was a without calculator. I think I retired this one a couple of years ago. And I want to say that each part was worth 3 points for the 9. So I don't know how you guys feel about that. Like, what if this was on your test? How would you guys have done so far? Good, bad, ugly. But it's a good problem, but it just got old after a while. So for part C, it says find the coordinates where the tangent line's vertical. Well, if you go back up here, you've got your denominator 2y minus x. So remember, a vertical tangent line is just you setting that denominator equal to 0. And I gave students 1 of the 3 points if they did that correctly. Now here's the part that kind of freaks kids out, at least the year that I gave this. How do you solve this and get an x and a y, right? Because it's one equation with 2 variables, and I know that that's a little tricky. So the thing to do is to solve it for x, add the x over, and then go back to your original problem and replace the x's with 2y. It's basically using the substitution method. I had a lot of students in the past not pick up on that, but I'll be honest, I had a lot of good students get like a 7 out of 9 on this problem, or maybe they missed a point or 2 and got like a 6 or a 5 out of 9, which is not a bad score, right? If you guys can average 5 points on the free response questions on the AP exam, you will guarantee yourself a 4. Right? You'd have to absolutely have a meltdown on the multiple choice for that not to happen. So if we go back, 2 times x is 2 times 2y plus the y squared minus x times y would be 2y times y. Is that 2y squared? Is that right? 2y times y equal 3. So what do we got here? What we've got is -2y squared. No, I'm a liar. -1y squared plus 4y subtract 3 equals 0. Not a fan of this negative out in front, so I'm going to multiply by a negative. There we go. And then I can factor, and I promise that this will factor. Problem was too difficult as it is. We don't want something that doesn't factor. So y is 3 and 1, and then it wants to know what are the points for which that happens. You could plug these back into the original, Or make it even better than that, just plug them into this equation right here, because you just basically solve the system so you can use either one. So when y is 3, x is going to be 6. And when y is 1, x is going to be 2. So those are the two answers, you guys, for that part. Okay? I'm looking at 20. Well, gosh, what was it? 20. 20 was the other one. I think we can hit 20 up, guys. I think I can get this done in just a few seconds. So we can take a peek here. And number 20 here, it is a standard. This is the last question. So I was just notified that I have to help my daughter study for something. So, okay. So we're going to go ahead and take a look at this. And you could use method 2 or method 3, but I'd like to use method 3 because it's a little bit more foolproof with most of the problems that we want to do. So let's write the formula, right? F prime, the derivative of the inverse at -12 is 1 over the derivative of f evaluated at the inverse of f at -12. So again, there's two things that we have to do, and you can do them in any order that you'd like. One thing that you have to do is find the derivative of f. Okay, so here's our f, and you'll find out that this derivative kind of cleans itself up nicely. The 3 comes out in front, cancels with the 1/3, so you have x squared plus just 5/3. So that wasn't bad. The next thing that you have to do is you have to let the f of x be -12, right? And then you've got your 1/3 x cubed plus 5/3 x plus 2. Okay, you guys are probably starting to see that these problems look alike. The patterns are the same. That's why I have you guys practice. That's why I give you so many things to practice. If you take full advantage of those, you all of a sudden start developing muscle memory, and it's no different than kicking a soccer ball, playing a piece on the cello, all of those things that so many of you guys are really good at because you practice them. Think about you athletes, how many times you guys are out on the court, out on the field. Think about the hours that you guys have spent in the band room, in the orchestra room, playing some pieces over and over again, right? It applies to my class, it applies to US history, it applies to Lang. If you guys can use those same mechanisms in your academia, you're going to really see your GPA climb, your class rank climb. It's one of the things that I try to teach you guys. Okay, I'll get off the pulpit and stop preaching now. Let's go ahead and solve this, and I'm a little scared, I'm a little concerned because there is no calculator next to this, so we have to start trying x's on for size. I don't think x equals 0 is going to work. Would you agree? In fact, I'm going to go out on a limb and say, I don't think x that's a positive is going to possibly give us a -12. I don't think x equal -1 is going to give us a -12. In fact, I think when x is -1, we get 0, if I'm not mistaken. How about we go x equal -2? If x equal -2 doesn't work, I'm going to quit. I literally am going to maybe quit. So if we let x be -2, I get -8 over 3. I'm not a fan of that. I get -10 over 3. I'm not a fan of that. Plus 2. 18/3. What's 18/3? Is that anything? That's nothing, is it? I don't think we have an answer. Oh, okay. I got one more in me, guys. I'm going to try -3, and I promise if x equal -3 doesn't work, I am going to quit. So if we plug in -3, -27 over 3 is -9. 5/3 times -3 is -5. You agree with that? Add 2. And what does all this make? Well, looky. It is -12. Good thing we persevered, right? Just when we were on the brink of giving up. I almost told you I was going to give up. I stayed with it. All right. So basically, to solve this problem, this is your denominator because that's your f prime. And you replace the x with -3, you guys. So when we simplify this, we get 1 over 9 plus 5/3. The 9 is the same as 27/3, is it not? So all of the stuff in the denominator is equivalent to 32/3. And once that's reciprocated, your answer should be 3 over 32. And if I went, too fast, I feel like I've got a pretty good write-up on this one that you can see on the review guide. So you should be okay. So, all right. I know that I may not have gotten to everybody's question. We went a little longer tonight, but it makes sense because it's probably likely that this might be the most challenging unit so far. But you guys, it doesn't mean it's the hardest test. It doesn't mean it has to be the hardest exam. I've got a pretty good feeling. I think we're going to come through it pretty well. Whether or not it'll be like Unit 2 well, I don't know. I bet it's going to be better than the limit test. All right. I think most of you guys are working pretty hard. All right. I am going to shut us down and get this thing recorded. Anyway, I hope that this helped you. And just kind of looking ahead, we will be around tomorrow morning if you guys want to come in for help. I'll probably put a little bit of priority on the period 6 people. We've got SRT tomorrow, even though it's the hour delay. And then, of course, I can stay after tomorrow. I can work with anybody that needs a little help then. And then I'll make sure that I'm also in Thursday morning for any help. All right. All right. You guys are awesome. Thanks for sticking around for the long session tonight. And I'll see you at school. Have a great evening.